By default, NTP doesn't provide security. So the client is trying to contact an NTP server. The NTP server responds. The client just accepts whatever was sent to it. That could have been a rogue NTP server, meaning you are getting bogus time that is potentially not accurate because some hacker's trying to cover their tracks as to when they did a particular attack on your network. So we want to make sure we have accurate time, but we want to make sure that it's coming from an accurate or authentic time source. So how can we do this? Well, we can set up authentication. Now, authentication benefits the client. Let me repeat that. Authentication benefits the client. Why? Because the client sends its NTP request to the server. The server sends the response back. And when the server sends the response back, it's going to include authentication information in the response. The client will then determine whether that is correct authentication information or not. So if it's not, then you're not going to synchronize with that server. But if it is, you will synchronize with that server. So what do we need to do? We need to set up the server with authentication information, and the client has to be set up with authentication information as well. And it has to be the same information because we're going to be generating a hash, and it's the hash that's going to be compared when we are verifying whether the server was successfully authenticated or not. So we set up our NTP authentication key. We specify the hashing algorithm. We're using MD5, and there's the key string that's going to go inside, or pardon me, the key string going to be used as part of the process to determine the hash. And in this case, it's my password. Let's come up with stronger key strings in our organization in the real world. NTP authenticate to turn on authentication, and then we're configuring our trusted key. In this case, we're using trusted key of 1. Down below for our client, same commands. NTP authentication key, making sure we're using the same hashing algorithm and the same key string. Turn on authentication, make sure we're using the same trusted key. And then here, we need to specify the key when we're identifying the NTP servers. So the client has the NTP server command configured on it, 10.01.22, and we're saying we're using a key of 1. So now what happens? When the client sends its NTP request, is it sending authentication information in the request? No. What it's going to do is it's going to wait for the response to come back with the authentication information in it, so the hash. And then it's going to compare its computed hash to what is returned. If it's accurate, or the same, pardon me, if it's the same, then it's authentic and we will synchronize. If it's not the same, then we won't synchronize with that particular server. So that protects the client. How do we protect the server? Well, why do we have to protect the server? Well, do we want the server to hand out time just to any device? No, we don't. We don't, because we don't want the server to hand out time to rogue devices or devices that shouldn't be receiving time from our NTP server. So what we can do is we can control who we hand out NTP time to using access groups. So in this top example, we're setting up an access group between peers. So we are controlling who we can peer with using NTP. So this access list is saying that we will only do NTP peerings if the devices are from 10.1.0.0 through 10.1.255.255. So this ensures that the server will not peer with anybody unless they are from that particular IP address. Down here, you can see the serve only command was used instead. So NTP access group serve only. So in this case, we are identifying which clients the NTP server will serve. So they're only going to hand out NTP timing information to those devices with 10.1.0.0 as an IP address through 10.1.255.255. If it receives an NTP message from anybody outside this range, it will not respond back with NTP synchronization information. So we add a layer of security. However, it's also important to note now that we are going to have to control where the NTP requests are sourced from on our clients. Where are they sourced from by default? They're sourced from the exit interface. That's right. So whatever interface the NTP request is sent out of, that is the source of the NTP packet. So how do we control the source now? We can control the source by using the NTP source command. So we can specify on all the devices that they're going to use a specific IP address that is associated with a specific interface. So in this example, they're using loopback 0. So all NTP packets for this particular device are going to be sourced from loopback 0. So it's important that that loopback 0 IP address is an IP address that is part of that access group that was specified. Because if it's not, then the devices aren't going to receive the NTP information that they need.